Okay. Next topic, Riemann's mapping theorem. Very, very important that you need to study that one. Riemann mapping theorem. Let D be domain. Any simply connected domain in the plane other than the entire plane itself. Then there is a one-to-one analytic function that maps D onto the open unit disk. Okay, unit disk. Once more, what is the meaning of Riemann's mapping theorem? Let D be any simply connected domain in the plane other than the entire plane itself. Then there is a one-to-one analytic function that maps D onto the open disk. Moreover, one can prescribe an arbitrary point of D and the direction through points which are W be mapped to the origin and the direction of the positive real axis respectively. This is a theorem. Respectively. Under the restrictions, the mapping is under the restrictions, the mapping is unique. Under such restrictions, the mapping is unique. Okay, once more, we consider on D that let D be any simply connected domain in a plane. Okay, you know plane other than the entire plane itself. Then there is a one-to-one analytic function that maps that is same like open mapping property, maps D onto the open unit disk. Moreover, one can prescribe an arbitrary point 1, 2, 3 like that, arbitrary point on D and the direction through direction through that point which are W be mapped to the origin direction. Okay, once more. Moreover, one can prescribe an arbitrary point of D and the direction through point which are W. That is the image of that one. WB mapped to the origin and the direction of the positive real axis respectively. What is that meaning on? That is mapped to the origin and also directed to the positive real axis respectively. Under the restrictions, the mapping is unique. Under the restrictions, the mapping. Moreover, we can say that this is a this mapping is unique. That is, what is the meaning of this one? Riemann's mapping theorem. Let D be any simply connected domain in a plane other than its entire plane itself. Then there is an one-to-one analytic function that maps D onto the open disk. Moreover, we can prescribe and arbitrary point of D, and the direction through point that through which RBWB map to the origin, and the direction of the positive relaxed aspect. Under the restrictions, the mapping is unique. Okay. Then we studied what is Mobius transformation or fractional transformation or bilinear transformation. Okay, that is Mobius transformation. Mobius transformation have one more name. We can say that Mobius transformation or linear transformation or bilinear transformation, or what is that one? Fractional transformation also. Okay. Mobius transformation, bilinear transformation or linear transformation, fractional transformation, like that. Okay, that's the points. We can say that for Mobius transformation, the transformation of the form is the transformation of the form W equal to AZ plus B by linear form CZ plus D is called a bilinear or fractional or Mobius transformation. Mobius transformation. Then second point, that is of the form W equal to AZ plus B by CZ plus D. Second, bilinear transformation. Bilinear transformation is a combination of translation, magnification, rotation, okay, rotation and inversion. Okay, translation, that figure we can translate on another form or another place. Magnification means we can reduce their length, breadth, height. Okay, like that. Rotate means we can rotate that figure to another plane. And inversion means W equal to 1 by Z means the inverse of that one is Z equal to 1 by W. Okay. So this is the definitions, 2 points of bilinear transformation. For more explanations, I will give you consider the simplest mapping of all, the translation defined by the function. If one figure to another figure to transform, we can use the definition that is defined a formula W equal to F of Z equal to EZ plus C. This is the translation formula where C is a fixed complex number. Complex number of the form is equal to X plus IY. Okay, remember this is the real part and this is the imaginary part. Okay, I will draw one figure. Z plane, Z plane, X, Y, O, A, B, C. Okay, can I translate this one? That form is W equal to Z plus C. Okay, U, V, W plane, translate that. C, A dash, B dash, and C dash, central C. Okay, this is another. This is the form of translation. Then next, okay, the entire complex plane, the entire plane, the entire complex plane is mapped one to one itself, one to one onto itself, and every geometric object is mapped onto a mapped onto a congruent object. Rotations are quite simple. Rotations are quite simple. So here we use simple. What is the that things happen for rotation mapping? The entire complex plane is mapped onto itself, and every geometric object. Geometric object, we know that geometric box like that. Geometric object, we know that every geometric object is mapped onto a congruent object. Congruent object. Rotations are quite simple. So rotations, we can use the form W equal to F of Z equal to E raised to I phi into Z. Okay, remember for a translation W equal to Z plus C, and for a rotations we can use E raised to I phi Z. E raised to I phi into Z for rotation. This is equation 1 for translation. This is equation 2. Remember that one. Where phi is real. Phi is real. Every point is rotated about the origin through the angle phi. Such transformations are also on to one mappings one-to-one mappings of the complex plane onto itself. Plane onto itself and map geometric object object onto congruent objects. Congruent objects. The mapping. Then next, the mapping. Please study these things. The mapping defined by, okay, I need to draw one figure related to rotation. Okay. Z plane. X, Y. Okay, similar figure. O, A, B, C is translated to the W equal to e raised to I phi Z. Or rotation. Example figure. W plane, same figure rotated the center. That is only the difference. This is phi angle A dash, B dash, C dash. Oh, okay. This is a little bit lean. So fatty. I will draw it. A, B, C. Rotated at the center. Okay. The next. The mapping. The mapping defined by W equal to F of Z equal to rho Z, where rho is a positive real constant. Real constant. Simply enlarges or contracts the distance of every point from the origin by the factor rho. Hence, such a transformation is called magnification. Okay, magnification. We use this in a Photoshop. Okay, like that. It's a it will becomes enlarge or contrast. It will large up that figure, or it's reduce the figure size. That things are, we can say that this is magnification, the application of the form rho into, is the rho means it's how that is a length is 10. We multiply that into 2, we get 20. That rho is the magnifying factor. Otherwise, half into 20, we can reduce that figure. That is, so we can, in the magnification, we can use the form rho Z. Here, e raised to I phi Z. There, Z plus C. Okay, mode W1 minus W2 equal to these things. We saw one theorem, F of Z1 minus F of Z2. that is equal to, what is rho z1 minus f of z is rho z, so we can write rho z1 as rho z2. Rho is a constant, we can, the distance between them is also rho modulus of z1 minus mod z minus mod z1 minus z2. These things we already proved in theorem. Magnifications, thus rescale distances, okay, distances, and since they are conformal, preserves angles, consequently any geometric object is consequently any geometric object is mapped onto an object that is similar to the original. The complex plane is mapped onto itself. Okay, listen, magnification plus rescale the distances. Okay, preserves angles. Consequently, any geometric object is mapped onto an object that is similar to the original. The complex plane is mapped onto one or onto itself. Okay, then here also I will write a figure. Is a plane. Oh. A, B, C, same. Z plane, W is equal to 2Z. We can say that in the place of 2 is rho, any constant. 2Z is an important term, W equal to 2Z. That is W plane. Now enlarge the plane, enlarge the figure. UV plane. This is W plane UV. Okay. O, A dash, B dash, and C dash. Okay, some more problems we will do it with using examples. Okay, on the next class I will explain that one. In this I will say about the MOBIUS transformation. What is Riemann's mapping theorem? Very, very important theorem. You study that one. Then what is bilinear form? It will preserves the translation, magnification, rotation, and inversion. Inversion of the form W equal to 1 by Z. That is, we know, again we can write it that in the inversion form Z equal to 1 by W. So we can say that this is an inversion formula of conformal mapping. So I will explain with the examples related to what are the reflection, magnification, and translation and rotation. Okay, thank you. Please study well. Take care.